Je to slyšet, jo? Tak dobré odpoledne. Mohl bych vás poprosit, abyste zaujali pozice. First question, anybody who doesn't speak Czech? Nikdo se nehlásí, tak v tom all right, so we're gonna need to proceed in English. Welcome. All right. Before, I'm sorry for a little delay. There are some technical problems which will be solved very soon. So I'll use the time to do a few introductory words. So thank you very much for coming. This is our first presentation, and we call the presentation FEL and FIT, which is the Faculty of Electrical Engineering and Faculty of Information Technologies of Czech Technical University in Prague. And we in the eClub, where eClub is sort of umbrella of this presentation, and we just, for the purpose of communicating our messages in an easy way, use this name, but in fact it won't be the whole Faculty of Electrical Engineering and Informatics, but only part of it, and we are working together in a group called Computational Intelligence Group. And we are the people who are interested in the sort of interesting new trends such as cloud computing and big data. All the presentation you will hear today are from the members of this team. It will be around 15 presentations, and all of them any of these presentations won't be longer than 10 minutes, and all of them are organized the same way. They will have three parts: need, approach, and benefit. Need, as you can see from the first one, is to explaining what is the problem. And so let me explain what is the purpose and the problem we would like to solve during this presentation. As well as you, as well as me, we all know that the cooperation between universities and industry is not great, and we definitely want to improve it. And I think that what is required is to start some communication, and while communicating, we should help each other. We should understand each other much better, and here are some few more words. So what will be the approach? The approach will be presentations, and the presentations are listed here in the order in which they will be presented later. And what would be the benefit? The benefit will be that we hopefully will start today some deeper cooperation, or at least will inform each other about what we do, what are our problems, and how to solve them. Companies typically need new employees, and working with universities is a great way how to engage with students and how to persuade them to work for new companies. And the university has another problem, that the teachers typically stayed or left or got stuck, whatever we would call it, at the university just after they graduated, and they typically don't have the feel for business, which is much faster and solves different problems. So these are the things we try to remove, and this will be hopefully after a while, or after we start deeper communication, the takeaways. So let me call the first presenter, which is Tomáš Vondra, who will be talking about our computational infrastructure, which we use in our research groups as well as for students.
Hello, my name is Tomáš Vondra, and I am a PhD student at Faculty of Electrical Engineering, and my topic is cloud computing. Unlike most other presentations you will see here today, I'm working with servers. The other people will present various ways to look at data, to mine data and find insights from the data. However, to do this, you also need the servers where you will do the computations. And cloud computing is one of the ways to get the necessary computing power quickly and elastically. My methods will benefit every owner of a larger number of servers, meaning more than 1 or 2 racks. Nowadays, most companies who own such infrastructure are using virtualization, which promised savings in money in the number of servers. However, virtualized infrastructure still has the drawback that resources are assigned statically to each project. For example, you need for example, new product. You will dedicate 4 servers for it, or in this case, 4 virtual machines, and you will leave it running all the time at the peak necessary amount of resources. With the private cloud, it is possible to dynamically reassign resources with a few clicks, start virtual machines from one image, and so on, which simplifies repurposing of resources. Another thing that the private cloud brings is separation of concerns. The infrastructure as a service abbreviation has the meaning that there are 2 entities, at least. One is providing a service, which is the IT department of a company, and the other departments, be it web services, emails, and computing, those departments can consume these services. And the IT department can focus on keeping this infrastructure in top shape, while the other departments care only for their applications. Big data infrastructure is traditionally separate from web serving and other purposes, but with the cloud, it is possible to merge them. So if you have other need for servers, and you already have some infrastructure and are interested in exploring big data, cloud is the way to get big data infrastructure quickly. There is a problem with that. The interactive traffic can be scaled quite easily. There are autoscalers and platform as a service tools, for example, which can simplify that. However, batch jobs, which most computations fall under this category, have the property that they eat all the capacity you give them. Therefore, it is necessary to somehow set the bounds for the batch jobs so that the utilization of the servers is maximized and the quality of service for the interactive traffic doesn't deteriorate. What is the approach to this? I am using time series forecasting algorithms to model the daily curve of the interactive traffic, which allows me to predict a few hours to a few days ahead the usage of the servers. Therefore, I see how much free space I have, which could be fed as input to a queuing system, which would then use the available space on the cluster and not anymore. Second thing I am studying is queuing networks, which is a concept from the theory of queuing, and this allows me to model applications. For example, if I know the number of clicks per second, I can model how much utilization it will have on the servers. And I can change the model of the infrastructure and see, for example, the response time of the application if the number of servers changes. Here you can see these two approaches. These are time series of two web servers. The first one you see is more neat, the curve is more neat. The second one is more spiky. The thing is that the more traffic you have on the web server, the better you can predict it. Because here the individual requests are not visible. You can see just the aggregate load on the server. While here you can see the effect of random arrivals as per queuing theory, and the curve becomes less predictable. Nevertheless, this curve is predicted 3 days ahead from the model. The fire around it is the confidence intervals 80% and 95%. You can see that sometimes the real values, which are the small circles, overshoot. But really, when you specify that you want 95% confidence, there are less than 5% of points which overshoot. These things are illustrations of queuing networks. You can see web servers modeled as a service center and a queue forming before it. Then the requests from the web servers have to travel a network, go to another tier, then to go to storage tier, and then they would return to the client. And when you model a system like this, you can get the latency if you, for example, change the number of servers. The benefit of this: firstly, if you don't have any big data infrastructure yet, the cloud is the way to go. You can have a small cluster anytime you want. You can even spawn a small cluster of Hadoop just for one computation and then kill it when you don't need it. Secondly, when you have some smaller computational needs, however, they are all the time, they are persistent. These methods I have presented offer increased utilization of the servers because they are not dedicated to just one function, and then they can, for example, serve web servers for the day and do computations in the night. And if you don't have needs for big data yet, predicting the usage on the servers can help decrease power usage because you can turn off unused capacity in the night. What I do in the group is to prepare infrastructure, for example, for teaching subjects. We have done internet application development, where the students get instances, access to virtual machine instances on a private cloud. We are using OpenStack, where they program the Java backends for their Android applications. And now we are teaching a big data subject, where we are using Hadoop over OpenStack. We are using infrastructure in data center PSEC, about 2 racks of Blade servers. Each student gets a small cluster, and then we are prepared to add one cluster for example, scaling experiments. So, any questions?
I think that let's postpone the questions because there'll be another presentation which will be about similar topic, which is control of resources in a large scale center. And this is going to be presented by Tomáš Bartoň. Oops, here it is. Doprava.
Okay, good afternoon. As it was said, this presentation will continue with this topic. So what we are trying to do is to have a scalable infrastructure which is fault tolerant, does automatically load balance, and effectively can utilize all the resources. This is something that many companies already provide. So, for example, you have the Google Computing Cloud or Amazon Web Services, which provides pretty much this kind of features. But if you want to have it at your private cloud, you need to use some of the techniques like these big companies are using. So, for example, we have a problem that we have some services. By service, you can mean, let's say, a web application, or it might be some other application that usually requires some network, some processors, etc. And you have some batch jobs. Batch jobs, in our case, are some kind of computational jobs for machine learning, let's say, or for analyzing big data or whatever. And we want to assign these jobs to different computers. And this could be kind of difficult task if you let's say don't know how many computers you have available, what are the current usage of all the resources, and typically as a programmer you don't want to deal with this issue. So we're trying to deploy an application which is called Mesos. It's an open source project which started at University Berkeley in California. And this project provides us the ability to treat a single a cluster of computers. We can have thousands of nodes, and we can treat them as a single computer. This is like it should look for a software developer. So you can run any application, and Mesos will take care of allocation of all the resources. So typically, your application will request some processors, some memory, and Mesos will take care of allocation these resources on the physical cluster. On top of Mesos, we can run many frameworks. For example, Hadoop is supported. You can run many databases like Cassandra and many other applications. The advantage of doing this is that you don't have to care about failures. Like if a single computer fails, you can replace it. But meanwhile, Mesos will allocate the task that was meant for this computer to another computer. So you don't really have to care about the hardware. You just allocate your job to Mesos. The advantage of doing all this is that you can really use all your available resources. When some framework is not computing or is not using the resources, you can scale some other frameworks, so you can fully utilize all your available resources. The Mesos project is relatively new, but the community is growing very fast, and currently is running in production. Twitter, for example, they have thousands of nodes running Mesos. Also, companies like Airbnb and Facebook are starting to deploy Mesos on their servers as a kind of operating system for the cluster. So that would be all.
Very good. So some questions, because we are closing the block about efficient cloud computing or clusters, etc. No questions? All right. So in that case, Tomáš Tunis, where are you? Over there, is going to talk or start the next block, which is going to be about document classifications and related stuff.
Hello. My name is Tomáš Tunis, and I'm a PhD student at Czech Technical University, and my area of research and interest is mainly text mining, and in this specific case I will be talking about document classification. So in today's world we are literally flooded with enormous amount of data, and if you forget about videos and images, pictures, what we are left with is just text. So a natural problem is about finding what the text is about, and basically it's about finding basically dividing the documents into categories. And you may have your own categories, or you may let the algorithms and the approaches we are working on to find out the categories on their own. If I may, I will make a simple example. For example, take any news aggregator that collects articles from different sources, and if the collector doesn't know anything and you would like to, for example, read something about politics, it needs to find out what documents are about politics. So that's basically what I'm doing. The approach, I was thinking about how to describe it without going into technical details, but I didn't know how to, because therefore the presentation will be quite short. So I will try to go through it short and hopefully clear. The document classification on its own is practically very well developed and researched field. And there are plenty of models and algorithms. And these models are divided into basically two classes on their own, supervised and unsupervised. And this is basically true globally for any machine learning approaches. In supervised learning, you know what the categories are. You have your own list of categories and you have the documents. And these documents are already classified. And you know the classes. And you want to learn a model that will, based on these existing documents, learn how to classify a new unseen document. So, yes, okay. So I will go talk about this picture on the right. Hopefully you can see it from the bottom. So as I said, you have already documents that are classified. So you have the categories. The first approach, that's basically on the human. You extract features from the documents. That's basically, for example, the simplest representation of document may be how many times a particular word appeared in the document. And these representations of documents, together with the class, the category, goes into this black box, let's say. And this black box has parameters on its own, and the algorithms are fitted such that when you present it in production, a new document, the model will predict the class. And that's basically it. The second approach is unsupervised learning, and I think you will be hearing about it in the next talks, so I will skip it. But basically it's about that you have no categories and don't know what the categories are, or you basically want to find out some interesting categories in the documents on its own. And so there are models that allow you to do it. So there is a way how to find out, for example, interesting categories in the collection of documents. So next slide. What are the benefits of this? Basically, it's about eliminating the human work from the process of classification. Everything is automatic, so you can not only organize your documents, you can, for example, extract topics or find out what the genre of the documents are, or you can, for example, categorize the results from a search. When you, in a browser, for example, search for something, there are search engines that already classifies the resulting answers. And maybe the interesting part is the customer preference identification. That's, for example, when you think about how ads are presented to you on the pages, then the system that's presenting the pages keeps track of what pages you visiting, and according to what categories the pages are categorized into, the larger model can identify what are your interests, so that the ads can be targeted basically on what you are visiting or what you are viewing and what are your interests. So basically I think that's it, and if you've got any questions, please ask.
Okay. Some questions? Yes, please.
Thank you. Which model are you using for classification these documents?
Well, I'm more about. I'm more interested about these features, about the representation, but basically the models are linear separators like SVMs, or basically random forests, or any kind of like KNN. If you, I don't know if all others know what I'm talking about, but basically that's it. I think the models, the human part is about the feature extraction. I think most of the machine learning is basically about feature extraction, and the algorithms and so on. These are basically made for us, and so the tuning of the parameter, the black box on its own, it's about selecting the right model, okay, the algorithm that trains it, but basically all that, the performance on the final model is about the features you feed the model or the algorithms with in the training process. So that's it, maybe. Hopefully I answered your question.
Okay, so we will continue in document processing, and the next speaker is Tonda Novák.
Okay, hi. My name is Tonda Novák, and I am focusing on words and document representation in machine learning algorithms. Sorry. Yeah. So the thing is that most of the machine algorithms can process text data directly as a sequence of characters. They usually work with the numbers and numerical vectors. So in order to use them, we usually have to create some numerical input into these algorithms. And what we usually do is that we are just counting the words inside just some text files or such things. The disadvantage of this approach is that we obviously losing quite a bit of semantical information when we just replacing the actual words by the index into the vocabularies. So what we are trying to do is to create more informed representation of words. And basically we are trying to do that by assigning a multidimensional real value vectors to these words in training set. And we want to preserve some interesting properties of these words. For example, that the words with similar semantical meaning should be also close to each other in the space of representation. Or we want that the semantic relation of the words men and women should be about the same as the king and queen. And the great thing about this approach is that it's completely unsupervised, right? So you need just big text files and you find this representation from it. No humans annotators are not required. So by using this more informed representation, which contains some of the semantical meaning, they improve many tasks, such as information retrieval, knowledge representation, questions answering, and other things. Here I have prepared a small animation, but unfortunately it doesn't work here, so I'll just send you the link after the session. But basically, this you can see some nice clustering by this representation. Each point in this space represents one document, and I don't know, you probably can't see it, but the blue dots represent the documents about I think that's about the sport, the red ones are about the traveling, and green ones are about the smartphones. As you can see, this semantic representation nicely cluster these documents. Okay, that's all. Thank you.
Very good. So, some questions? No questions? Okay, so let's proceed. It's already here. And this will be the next speaker, Jan Černý.
Okay. So good afternoon. I will be talking about predictive models, and need for it is pretty apparent because people always wanted to predict the future, and knowing what will happen next is the key to success in any business, in any field. So let's take a look at the situation in the market or in a business now. How is it with predictive modeling and with data mining in general? And the situation is that most companies don't use the riches and knowledge they have hidden in their data. And those companies who do use data mining often do it manually. I explained what I mean with manually. Often they have some expensive BI software and a team of analysts which do a lot of repetitive work with each new use case, each new problem over and over again. Imagine that you would use in your company a predictive model in every situation, on every problem, where it even makes a little sense. That's like tens or hundreds of models for each company, which is not feasible to handle it the old way. So how to do it? We are automating this process, and by the process I mean constructing new algorithms, combining those algorithms, optimizing parameters of those algorithms, but also preprocessing like input selection, data transformation, time window selection, and so on. This problem is so complex by itself that it cannot be handled by brute force or classical algorithms. So we utilize artificial intelligence to mimic human problem-solving skills. I'm going to illustrate this. This concept was illustrated nicely by Netflix. In Netflix prize, Netflix is the largest US movie provider, and they had an open prize for $1 million for the one who would improve their model by 10%. Thousands of people worldwide was in this competition, and after the 2 years, someone won the competition, won the $1 million. But the point is, these people did the things I was talking about at the beginning of this slide. They were creating new algorithms, they were combining those algorithms, optimizing the parameters, transforming the data, and so on. So they were doing this stuff, but manually again. Sorry. I'm going to show you here some use cases so you have a better idea what you can do with this technology, and I'm going to describe briefly two of them. First one is churn prediction. When we are predicting the customers who are going to leave, we are doing it for the telco operator, and we managed to obtain 70% accuracy in 2 months advance, which was also 2 times better than base models commonly used in BI software. Another use case is oil additives detection, where we managed to cut the time of detection of 32 additives from days to minutes, and the costs from millions to almost nothing. Because previously it was done in laboratory when you need expensive laboratory equipment and it takes a lot of time. And we managed to, with the same accuracy, same precision, we managed to do it with predictive models from infrared spectrum, which can be measured by a handheld device. So the benefits. First is precision, because each percent of model precision can be transformed into profit or expense saving. So the difference between 71% accuracy and 73% accuracy can be tens of millions. Second is possibility of new services with these technologies which weren't possible before. Second is automation, because with these automations you and your analysts can work on more creative things, which would again bring you more competitive advantage instead of doing same tedious work over and over again. Third is speed. Our models are built to have real-time responses, are able to handle big data, and are ready to deployment for cloud infrastructures or into private infrastructures. And last but not least is transparency. Sorry. Because we understand that you need to trust the models and you need to know what's going on in there. But we built our products and our services so you can use them without any expert knowledge. But we don't offer black box models or black box services. You always can have more information so you know what's going on and why it's going on. So our predictive models don't offer only the predictions, but also the certainty of those predictions, whether they have support in the data for those predictions or not, or reasoning why they're making certain predictions. All this and many more is provided by Mogen company, which is our university startup, and whose goal is to bring those technologies from university and science into business and daily life, so you could turn your data into knowledge and money in an automated way. So I thank you for your attention, and I leave space for discussion.
Maybe someone can tell us some good joke. No, nobody? All right, so we have to proceed to the next speaker. Next speaker is Pavel Kordík. Here he is.
Hello.
Hi.
So, I'm Pavel Kordík and I got stuck at the university for 12 years already, but I still have some research interest, so I will tell you something about it. And before I tell you about research interest, I must say that everything what you hear is applied research, but what you don't see is the basic research behind it. And basic research is very important because it's about improving algorithms. It's not just about taking existing algorithms and applying it to solve your problem, but we can also improve algorithms, and this is also our goal. And all our colleagues are working on their PhD degree, and they will not defend their thesis if they don't contribute something. So they need really to improve algorithms, and this is also what we can offer and what we are offering. So what I will talk about is optimization in a general sense. You can imagine that you have some problem in the company, and this problem can be solved, can be optimized. For example, for a logistic company, you can optimize the traveling salesman problem. Also, you can optimize some parameters of your business processes to get better profit. So it's called continuous optimization. And we work on this optimization algorithms to improve models and to improve the way how we can solve your problem. What you have seen already is that we are able to do it in an automated way as well. But in order to do it, we need to do a lot of experiments on different benchmarking data, benchmarking problems, and fine-tune the optimization techniques to be able to find the most fitting one, and then generalize the knowledge to be able to select the best algorithms to your problem in an automated way. So this is just a few illustrations about how we discover the algorithm behavior and how we can improve it in a way to solve problems of continuous optimization and also optimization in a discrete way. So the optimization is not only problems we are dealing with, but also a very interesting research domain is meta-learning. It means learning to learn. So in fact, it's that when you have some problem and you solve it, then when you encounter a problem which is similar, you are able to apply already acquired knowledge to solve it better, faster, and more efficiently. So this is also what we are dealing with, and we are trying to fine-tune. Thanks a lot. Any questions?
Okay, so no more questions? Single question so far only. All right, so the next speaker is Tomáš Řehořek.
So, good afternoon, ladies and gentlemen. My name is Tomáš Řehořek, and the topic I would like to talk about today are recommender systems. I will introduce what recommender systems are and will present some ways we are trying to put recommender systems into practice. So, as I mentioned at the very beginning of this slide, where in the recent years there has been a huge growth in the era of e-commerce. There are a lot of e-shops, web portals, newsreel portals on the internet, IPTV or video streaming services. And all of these have one thing in common. All of them have a huge amount of products. They have a huge catalog of items, of products being available to the users. But you know, it's not so easy to find a way how to present such a catalog, such a huge number of products to a given, one given user who comes to your website or to your portal. Probably all of you already know what recommender systems are. If you are using, by example, YouTube, then when you are watching some video, then you are giving some personalized recommendations, some other videos that you might also be interested in, that you also might like. So that's a recommender system. And well, today's problem is not to aggregate products that your customers will be interested in. Probably, if you are running an e-shop or some kind of video streaming service, then probably you already have some interesting products in your catalog. But the deal is the problem is how to present the interesting products. If you are running a ticket portal and some guy comes to your website and the guy is interested in, I don't know, maybe techno music, then is it a good idea to offer him a ticket to an opera? Well, I guess not. You should offer him some DJ, some party, yeah? And that's what's the point of recommender systems. So we need to find novel ways how to present your catalog to the users such that they will find what they want. Another thing which is closely related to recommender systems is advertisement personalization. It often happens that if you put advertisements into your website, that the users will find it annoying. The users don't like advertisements. But if the advertisement is personalized, if it's targeted, then you may turn it into a useful service. So I hope the motivation is quite clear. Let me talk about the approach. Well, as I mentioned, the approach are the recommender systems. Here on this slide, I mention many of the algorithms. Well, the algorithms is what we are really good in. I could talk about the algorithms for hours, but because I only have few minutes, let me just briefly introduce two main concepts used in recommender systems. The first concept is called the collaborative filtering, which means when you have a lot of users who use your website, they view videos, view web pages, read news articles, put some products into a shopping basket. All of these actions create interactions or click streams which can be analyzed on your server, and you can discover, you can look for patterns in these click streams. By example, you all know the frequently bought together feature on Amazon. If many people often view one video and another video, and a lot of people do that, then there is some implicit relation between these two videos, and you can use the data, the patterns discovered in the click streams to create recommendations. Well, and then the other approach is user modeling, or we call it predictive modeling. It's useful in situations when you don't have enough data in your click streams, when you don't have enough users using your portal, your service, your website, but you still want to offer a recommendation service. You still can do that. You still can recommend items by assigning the item some metadata. By example, a textual description. Yeah, if two items have similar textual description, what does it mean similar? Well, it may contain similar keywords, by example. Then you know these two items are similar, and if your user is viewing one item, possibly put it into his shopping basket, then you may offer similar items just based on the metadata, not the click streams. But indeed, you may combine these two together, and that's what we do. So I hope the benefits of using recommender systems are quite clear. At the very beginning of this slide, I'm saying recommender systems allow you to offer to your customers what they really want. That's a cornerstone of any successful business. Yeah, you have to offer products that the people want. If you don't have products, or people do not know that you offer products that they want, then your business won't be successful. Another thing is you may increase user loyalty. If users learn that your service, by example, video streaming portal is offering videos that they are really interested in, then they will like that portal. They will return to your portal. You know this from YouTube. The reason why YouTube is so successful is because it keeps offering new and new movies that the users are interested in, that users like. So it's based on recommendation, actually. Well, one thing you may ask, okay, will recommender systems increase my revenue? Will it be 10% or 50%? If I deploy recommender systems, will my revenue increase by 100%? Well, honestly, I cannot guarantee that. It depends on your system, on how it works, what the products are, on the very nature of your system. But what I can guarantee is that deploying recommendation will increase your current click-through rate. If you already have some banners on your system, on your website, and you personalize them, then definitely the click-through rate will increase. And the last thing I mentioned on this slide is win-to-win situation. Well, it's win-to-win situation for both the business and your customers, because the business will sell more products. That's definitely good for the business. That's what you want. But also the customers will be satisfied because they will find the products that they really want. So business wins and customer wins. Perfect situation. Finally, the last slide, I will mention something about the the deployment. My colleague Honza already mentioned that we are running a startup, a university startup called Modgen. In Modgen, we are developing production-ready versions of our algorithms. The algorithms that come from our research. So we have easy to use domain-independent API. We are offering a recommendation API. You may submit information about your products, about the click streams, and our API responds with recommendations. Another thing is that we have scalable cloud infrastructure. When we are talking about millions of clicks per day and about thousands or maybe hundreds of thousands of products, it certainly needs huge computational power to handle that. So we are running on a cloud infrastructure, And one thing that we are most proud of is that our recommendation API is fully real-time. As the clickstream comes to our API, the models immediately update, and it may take only a few milliseconds for the recommendations to change. So, if you are interested in our service, you may contact me personally after the end of the presentation. I would like to thank you for your attention, and that's it.
So, any recommendation? No questions? All right, very good. So thank you very much for great performance. And the next presenter is again Tomáš Bartoň, and now with the clustering.
As my colleagues already mentioned, clustering is an unsupervised technique to explore your data. And sometimes it's also called segmentation. You can use clustering, for example, to find different groups of your customers. So if you have a database of purchases, for example, you can find out that you have a group of customers who are doing, let's say, the 90% of the revenue. So this is definitely a group of customers you should somehow focus on. Either you can send them special offers, you can offer them vouchers, or treat them well, let's say. Also, you can use clustering to target on other groups of audience, and by doing clustering of your customers, you can focus better on their real interest. So you won't send them hundreds of emails per day, but you will send them just one email per week, and in that email will be exactly what they are looking for. You've probably seen some Google News aggregation. This is aggregation of news stories, and that's practical usage of clustering. There are employed clustering algorithms to group the similar news stories so that you will read the news story just once. This is how a visualization of newspaper stories might look like. You have to extract from the articles the words, and then you create some sort of graph where you connect the similar stories together, and from that you can get this kind of aggregation. We don't have to cluster just text. We can also try to cluster some different data. I experimented with clustering of time series data. So in this picture, you can see kind of messy data, and the goal is to find distinct patterns. And it might look something like this. You have some input data, and you split them into different categories. So, for example, if you have some financial patterns or any other patterns, you might look for these specific patterns in the data. So to sum it up, the benefits of clustering is that you can better understand your data. Also, clustering could be used to get labels for your data. So because most of the data that are available are usually unlabeled. So you have to label it somehow, and then you can train your predictive models on it. And also, clustering could be used as a useful data visualization to understand what is going on in your data. That's all. If you have any questions, feel free to ask. If not, okay.
No more questions. So Tomáš Borovička is the next speaker.
So hello. My name is Tomáš Borovička, and I will tell you something about semi-supervised and active learning. Actually, I will continue with on the presentations you already seen, because you heard a lot about predictive modeling, about clustering, etc. And what I do in my research is I'm trying to combine these techniques together, and that's because if you want to have a good quality model, you need good quality data. You need label data. You want to predict some behavior. You to have labeled data, labeled what is your goal to predict. And that's usually expensive to get these labels, because you need some people to do that. You have to ask some of your employees to sit, look at the data, and label each record with appropriate target. So it requires time. It requires human interaction. It might require experts, because not always everyone can do that. If you want just to label if on a picture is cat or dog, that of course you can hire anyone. But if you need something that's specialized to your business, then you need experts for that. And you also might need spatial devices that could be quite expensive. So labeling actually is quite a hard task. But without good labels, you just can't have good models. On the other side, unlabeled data, you have usually in huge amounts. You have a huge amount of unlabeled data. It's cheap. You have it already in your databases usually. So the question is how to combine or how to utilize this unlabeled data. Because if you will label everything, that will be expensive. So it's about money, time, and the resources you have for that. So the approach is, so unsupervised learning is if you don't have data labeled and you want to find some meaningful patterns, meaningful structures, some clusters of your customers or whatever, or some categories of documents. And supervised is if you have these clusters, this labeled data, and you want to predict, you want to categorize new examples you've never seen, new records, new customers, you don't want to where to categorize them, but you have some information about them. So, and that's what I'm dealing with, and it's called semi-supervised learning. Everyone knows that the information is in the data. They're just what is missing, the label. But there is some underlying information that has to be there. So why not utilize it? And that's exactly what semi-supervised learning is doing. It's utilizing the unlabeled data, combine it with labeled data, and usually it yields greater performance than standard supervised techniques. And another question is, if you have millions of data, there is probably a lot of redundancy. A lot of customers or a lot of your examples are very similar. So if someone will label it, then how they should label? They should label everything. They should just take from the first record to the last one and label everything. That's probably not the best way. So the active learning is actually there are methods that can select the most informative examples. So it will tell you, okay, to have the best model that you can get, just label these examples, and it gives you the most information possible from your data. And so that's called active learning. The application, there's several examples. Very typical example, if you read some articles about that, is spam ham recognition. That you have actually available a lot of emails. That's not a problem to have emails for learning, but to have well classified spam and ham, that's quite difficult because people usually they don't care if it's a real spam or not. If it's fallen in spam and they are not interested in it, that might be not spam, but it's just fell there. And similar is with ham. So you have a lot of emails, but you don't have good quality labels, and it's difficult to create good model. Biological experiments, that's an example when the devices that actually do the labeling are very expensive and take a lot of time. The experiment can take a few hours, but it can take also a few weeks. You have some strains and you are looking at how the strains are growing, and actually it takes 2 weeks, and after that you can label it how it behaves. It's very common to use it also in healthcare when you have a lot of records about your patients, and but you don't know exactly how which treatment is the best. But if you combine the unlabeled treatments all together, you can actually find the best way how to do it. And already Tomáš mentioned here customer retention. etc., or churn, you can actually use all your data to prevent this to happen. That you can predict if the customer will leave or not, etc. Natural language processing and speech recognition. Imagine that you have to label some speech, some record video or record audio. You have to listen it and label it, and that is a very difficult task. So there's really a lot of applications where you can use it. And there's actually only one benefit, but it's a huge benefit. And it's maximizing model performance with minimizing human labeling effort. So, yeah, and that's all for my presentation, if you have some questions.
Okay, so let's proceed to the next presentation. And we are getting to a presentation with the title Customer Behavior, and it will be presented by Ondřej Pluskal.
Hello, my name is Ondřej Pluskal, and I will be presenting customer behavior modeling that I'm dealing with on the university. It's my research topic and also my passion. I think I clicked twice. No. Oh, okay. So why would you need to use customer modeling or customer behavior modeling? Is that users tend to have some behavioral patterns then in your applications or in your using your services. For example, if you are a telecommunications company, users tend to use your phones like on weekdays or something like that. So you can recognize these patterns and then make some models for basically advertising. My research topic is about advertising, and I would like to make advertising better, because many times I was approached by my mobile provider, and he was basically making me offers that I did not need in the times that were completely like not. I could not even like think about something like to buy some unreasonable things. So what I'm trying to do is create models that would, for the customers, create the best offer in the best time, and the time is for me really important. You have seen many presentations about that said how we could present to the customers the things they want, but the research topic that I have is when do they want it. So I think that if you make advertisement at the right time, you can minimize two key things. These are advertisement fatigue and advertisement wear out. These are terms that say that a customer, when it's spammed with advertisement, he gets either angry and leaves your services, or he can get worn out and he will basically refuse every offer that you present to him, and he will your money becomes ineffective in this way that your people on the phone will call this guy, and he will always tell, no, I'm not interested because I've heard so many offers and I'm really not interested. So how you can do that? If you have some service, if you have some mobile application, or if you are in telecommunications, you log what your customers do, and here is the thing that I'm really interested in, about creating these models that would then on behavior of a new customer or already known customer would say the probability that they will purchase your newer product, or they will from using a free application they would go to the paid version of your application, and these models can assign the probability from the data that you have collected about the user's behavior, and then tell to your system, okay, this is the right time to advertise, or no, this is not the right time. From the data that we collected from our users, we really don't think this is the good time to advertise because nobody bought it. So I already made some models. This was for a company called ČVUT. It's internet games company. they have a pool game, and these are the things that you can do with the my models. It's that they will tell you if it's red, the person is likely to buy, and if it's blue, the customer is not likely to buy. And this system can provide you with the information when he is likely to buy. The benefits of this is that by using these models, they tell you when is the right time to buy for your customer. Is minimizing this advertisement wear out and advertisement fatigue. The customers becomes more happy because they do not get so much spam, and also all these models are automatic, as my colleague said already, and they can be updated. You can have monthly updates or something like that, and of course you will by decreasing the advertisement wear out and advertisement fatigue, you can get increased revenue because you will display advertising or phone to your customers less, and the effectiveness of your advertising becomes bigger. So thank you for your attention.
Okay, any question? Speaking about the right time and recommendation to improve your services, you heard already several presentations, and I guess this is the right time to request our services. So as to get more motivation, there is the next presentation about social network analysis, and this will be given by Miroslav Čapek.
So, hello. I want to talk to you about, or shortly talk to you about the social network analysis. Why we should bother about social networks and analyzing them. The relationships between people represents very important source of information. Who can talk to who, and who can convince someone else to do something. It's quite important knowledge or important thing to know. But you can apply the very same approaches to other things, like banking accounts. So which banking account is sending money to some other account, and so on. If I stick to the people, you can use this information in a lot of customer-related tasks. Let's say, so you can use this information to acquire new customers. Like if you have if you know that someone is your customer, you can talk to his friends and try to convince them to buy something from your company. You can use the very same approach for the customer retention. So if you know that some customer is angry and left you, so you can try to find his friends and try to convince them to stay with your company, or even to convince the guy who left to get back in touch. So, approach. There are some advanced graph analyzing algorithms, and we will apply them, or we can apply them to classical social network data like Facebook or Twitter, and we can examine like friendships and who is commenting on whose posts and how many likes the post gets, and so on. And the analysis we use is the graph clustering, which basically means to find parts of the graph which is strongly interconnected. So its example is on the right side. These are my Facebook friends, and you can see that there are strong clusters of people who knows each other. So there are there are friends from my elementary school, high school, from the university, etc.
the other analysis is to find influential people. So if these people, let's say, send some remark or some statement, all others start to comment it and talk about it. And also we can analyze other graph properties. So there's, for example, how to find cycles in transferring money in between bank accounts. So benefits. What you can get is the first thing, and the probably most straightforward, is to enhance your input set for some other analysis. So you can use these information from the social networks to for better clustering of your customers. You can use this information for let's say customer retention models and upsell models and so on. The next is to find influencers and target, say, advertisement for these influencers, and hope that they will convince their followers to buy the same product. So in this way you can reduce your customer acquisition costs and better target the marketing, again reduce the cost for marketing. Well, you can, the next presentation will be about sentiment analysis, so you can basically analyze the text of someone's, of some, let's say, news article or post in the case of social networks, and say this post is negative and or positive, and if you find some negative posting, you can find people who the followers of this guy who posted some negative experience and try to say them, hey, it's not that bad. We made some mistake, and well, say we can give you some discount or whatever. And in this way, again, retain some customers. Well, at this point, I would like to stress again that this kind of analysis are not just about social networks and people, but you can also apply the same analysis for the, say, bank accounts. So we can or mobile, who is or to analyze who is talking to who on phone, or who is emailing who in the company, and then just the social networks or friendship gets transformed into some other relationship between the entities. So now it's time for questions, if you have any. If no,
sorry. So let me introduce the next presenter, which is Jonáš Amrich.
Thanks. Hi, my name is Jonáš Amrich, and I would like to tell you something about sentiment analysis. As my colleague said before, sentiment analysis is about distinguishing between positive and negative comments or sentences in text. In our world, brand popularity is defined on social networks, and the way people communicate with brands is defined on the internet. So in this huge amount of posts, it's impossible to label sentiment manually by hands, and we need some algorithms to decide sentiment for us. Our approach is combining supervised learning and linguistic analysis, and together our models are much better than classical statistical analysis, because sentences are much more complicated than plain text. When you take a document and you do just analysis on the whole document, you don't capture these syntactical relations between words. When you take this sentence, which is a sentiment analysis, is not as cute as kittens and puppies are. And this sentence is, when you just count positive and negative words, it may seem that this sentence is positive, but we are talking about sentiment analysis, and this sentence is a little bit sad and negative because sentiment analysis is not as cute, but it's much more useful. So, benefits of automatic sentiment labeling. You can get product acceptance or popularity data from the internet. You can detect popularity of reviews. It can be reviews on Amazon or movie reviews and etc. And in combination with social network analysis, as my colleague said before, you can identify core fans or people who don't like you, and then you can do anything you want next. That's it. Any questions?
Okay, so the next presentation will be about synonym discovery, and Tomáš Veselý is coming to present.
Hello, I am Tomáš Veselý, and I will tell you something about synonyms discovery. Synonyms are words with the same or similar meaning, and two words are synonyms if they are the same part of speech. But in this rapidly language is evolving rapidly in this age, and new words are being invented as products are released every day, and users are disturbing words on the web. So we need some way how to automatically generate synonyms. And there are some features which synonyms needs to hold. For example, we need to create them time sensitive. For example, new PlayStation is synonym to PlayStation 4, but 5 years ago this would not be true, and it would be true that synonyms are that PlayStation 3 is synonym to new PlayStation 5 years ago. Also, synonyms need to be context sensitive. For instance, baby and infant is synonym, but in the term Santa baby, we can't replace baby with infant because it's name of song. Another feature is that synonyms need to be domain specific. For example, if we have some school-related articles, then CTU is synonym to Czech Technical University. But if we have some TV shows page, then CTU is synonym to counter-terrorist unit from TV show 24. So how to generate synonyms? The first approach is to use monolingual dictionary, where we have word and explanation what that word means, and the key idea is that synonyms will have the explanation similar, so we can generate the synonyms from that, but it isn't time sensitive because these dictionaries are very old usually and doesn't update. Better approach is to use large amount of text where we are looking for words which are used in the similar places in the text, and we can extract synonyms from that. And probably the best idea is to track the user behavior on the web on the full text search, where we save to the logs how the user clicks on the documents, and we can extract synonyms from that. As I said at the beginning, we are not searching for the synonyms from language point of view. So we also created applications where we are labeling words by their synonymity, antonymity, or if they are not synonyms. So benefits, we can use synonyms in translation or natural language generation, where systems which generates, for instance, articles, news articles, can use synonyms to make the text more natural. In full text search, we can use synonyms for query expansion. For instance, if we have query business definition, we can expand it for another query business terms. And also in product recommendations, we can use synonyms to match multiple products together. For instance, these two terms are same product, as you can see. Okay, that's all. Any questions?
Okay. So we got to the last presentation, I guess, and this is learning to rank. Unfortunately, Marek Modry, because of unfortunate family events, he wasn't able to join us. His presentation, just to quickly mention what it is about ranking certain documents or certain products or certain items which can be described by some kind of vector describing several features, and he is developing an algorithm which would help you to rank the products by quality or by by other different criteria which you can choose. So I wouldn't get to any more details of this, and I would like to say thank you for joining us. We have recorded all the presentation, and we would like to make the text presentation available on the web. So who would be interested in it, leave me your business card, please, and we will mail you with what you've seen today, so as you can back to it and deep into the details. The next thing is that we certainly would be happy to stay in touch with you. So those of you who would be interested in talking about certain of these presentations in details, or to find out some details, or some of you who would like to apply something what we been very, very briefly just describing, please again get in touch with us. Leave me your business card. We will mail you, or we will establish some contact, and we would be very happy to engage and see what we can do for you. The next thing is that we have several different means how we can cooperate with you. We have a portal where you can leave ideas for the baccalaureate and master thesis, or probably maybe also for doctoral thesis. We have also, or we are preparing also incubator, where we'd like to work with students on problems which will come from the industry. So again, you who are representing a company and have some good ideas or some problems you would like to deal with, and these problems are from the field of computational intelligence, again, leave your business card, and we will try to get back to you, formulate the problem, and try to find students who would help you, or who can solve the problem. So the next thing is that we would be interested in your feedback, in the sense of suggesting what you are interested in, or would you like to solve, or what you would like us to focus at, we also would be certainly interested in who are the people you will be interested in employing, because this is one of the tasks of the university to prepare students for good business performance. So again, if you have any comments, suggestions, what we should improve or how you can help us, leave your cards and get in touch. So that's all, and now if you can still spare some time, get into networking and let me know, give me your response. So any immediate response, or shall we leave it for networking?
A lot of interesting problems presented. Do you have like web demos somewhere where you can try the algorithms or the solutions in a simple way?
We have several different ways how to show the demos. Some of the demos are ready. They are scattered on different places, and right now we are in the process of putting it all together in one place, and this is sort of kickstart to put all this together and to get it under one umbrella in some unified form, because certain things are on GitHub, other things are in other different places. The documentation for this is written in that form and another form. So that's typical how it works at universities, and we'd like to join forces, and this is also the reason why we are here with our friends from a different faculty, but we work already for quite some time together. So we'd like to be, in front of the audience as one group and put everything in one place, so as those who would support us or who would like to work with us have much easier access to the information. So thank you for the question. Some more questions? All right, so thank you very much for coming, even on Friday afternoon, and let's get to networking. Thank you.